Hello and welcome back to our decomp tutorial series. Today we are going to be talking about field effects and how to create them. Now, field effects get very complicated. They can be pretty simple or very complex. They range from, the Poke Center creating all the little Pokeballs and having them, flash and make their sounds, to just setting up using Surf and switching the player avatar state over to the Surf, icon, the surf graphics, to creating dust, footprints behind you, the splashes when you're in the water, the grass rustling as you walk through it and cut it, the heart icon above the emoticon stuff, like the smiles and hearts and stuff above the NPCs and Pokemon. In my case, I use them for a lot of my Zelda stuff. Not necessarily everything even necessarily needs to be a field effect, but I do it through field effects anyway, just because they're very versatile. It's just an easy way to set up a task and have it run from script. Although, to be honest, a lot of the time I don't need to be running my tasks from script. I can just run them from C. But when I started doing them, I was having trouble with the start field effect C function. At this point, I doubt I'd have the same problem. But this example that I'm showing you today is actually one of my Zelda examples, one of the first times I'm showing off some of the code behind it, and it's not good. It's really, really, really bad, especially this one. This was the second one that I worked on, and I've been meaning to go back and fix it up because I know how to now, but we are going to look over it today in its full, awful glory. So to start with, there is some stuff that goes on before that we're not going to look at when the item, when the bombs, we're going over my bombs for my field effect. There's when the item is called, when you use it, some checks are ran to see around the bomb, the left, left, up, and right from the bomb. No matter the direction, left, up, and right, or left, forward, and right, I guess, since it could be down if you're facing down. Left, forward, and right from the bomb to see if there is a bombable object, like a rock smash rock, or a bombable meta tile, which are meta tiles that I have added to a list that are bombable, which means that you can blow them up and reveal a door behind them, or you can blow them up and there's a door, under it if it's a tile on the ground. I haven't actually introduced that many different variants yet, because I just haven't I haven't added new tile sets to my game yet, so I just have the functionality there, and as soon as I add those tiles, I can just put them into this bomb list. But also, at the same time, the way I did it makes it that I have to do it in a little bit of an annoying way, which is one of the reasons why I want to fix my code. But I'm getting ahead of myself. We should talk about these field effects. So when you're calling a field effect from script, these are the two macros that you're using most often: do field effect and wait field effect. Now, the field effects, when you're calling them from C, it's start field effect and then the name of the field effect. We've already gone over these. We've talked, if you've watched all my videos, we have talked about the different field effects, like for healing the player, because we've created a PC, a Poke Center in one of my videos. But here we call do field effect, and we use a defined constant for this, and this is defined in include constants field effects.h. So here, as you see, we just add down to the bottom of the list. So the last one was this Deoxys rock, and we are going to keep adding down the list. I've added a bunch, as you can see, but this bomb is 68. So this just corresponds to the field effects script table, and it corresponds with index 68 in that table. That table is here. So this table, what that number means, if you want to know, is this table is where this field effect is pulled from when you do field effect, when you write that macro down, and then it goes down to number 68 and it finds it right here. Number 68 is field effect bomb, and it is this G field effect script bomb. And this is, we can scroll down to here, these are the scripts that actually call the field effects, and they have special The reason why we do it this way for these field effects is because they load palettes for us for the field effect objects. Not all of them need to load a palette. As you can see, my large chest here, it's just field effect call native, which just calls this function, the C function from the field effects.c code for my chest opening. But for this bomb field effect, we want to load a palette into the field effects palette slot as well as call this function. Now mine says load faded palette because in this repo I'm using the day-night system, so it's a faded palette here, but normally yours probably isn't going to say load faded palette. You just copy one of these from down here. Again, these say load faded because I have it set up that way. But anyway, that's if you're adding an item with your field effect at all. I have no idea what type of field effect you're looking at adding, but if you don't want a palette, you don't have to worry about it. Some of these, we'll see if I can find one. This one loads two palettes, the general field effect 0 and the Pokeball glow. So that is interesting as well. So from here, we are just calling this function field effect bomb after we load this palette. Now I'm going to look at this palette. We don't really need to copy it. We can just scroll to the top. So here's the palette right here, G sprite palette bomb field effect, and then here is the actual thing that is holding the palette, which we can go to object event graphics.h. This is just source data, object events, object event graphics.h. It is where the actual file is being saved into a variable for us to access a U16 array, const array, and that's where the palette's saved, and also the pick is saved here as well. So if you're adding a bomb or something, you obviously have to add an entry for it here. To add the picture into the game. You also need to add a graphics make rule. If you haven't done that before for something else, just copy one of these paths into there, and you'll find the graphics make rule stuff. It's pretty simple. It's just copying and pasting for the most part, and just adjusting for the size of your picture that you're adding. So we add the bomb here, and we also add, well, let's see where the actual bomb is. Here it is, object event pick bomb, and bomb2.png is the bomb, because I had problems with the first bomb, but I don't have those problems anymore, so I could switch it back, but it doesn't matter. So here we are defining this new palette, G sprite palette bomb field effect, and it's taking this G field effect object palette bomb, which is the actual palette itself, and we're taking this field effect palette tag bomb, which this is just the palette tag that we are giving to define its position, like where the position is for the field effect palettes. We give the, if we go to, if we go here, here is our object, our sprite template. This is the template for the sprite of our bomb. You need to create one of these for any field effect object that you're adding. We have the palette tag here, field effect palette tag bomb. We're also giving it sanim table bomb, spick table bomb. You saw me quickly scroll through some of that. Those are just the animation tables in the pick table for the bomb itself. You can watch my video on event object animations to see how the pick tables and the anim tables work, if you haven't used them already for different things. And then you can see from above they're just in this file instead of in a separate file like with the object events. And with the object events, the templates and the animations and animation tables are in a different file, and the pick tables are in a different file, but they're all in this file for the field effect objects. So here we give it g dummy sprite affine anim table because we're not doing any affine animations, callback sprite callback dummy because we don't need a callback for this sprite because we're not trying to run anything after it's gone or at any point after it's been created from the sprite itself. We'll be running stuff in our field effect. So here we're using a 32 by 32 sprite. This is pretty self-explanatory. We're just creating a sprite template for our sprite. We're giving it the pictures for our bomb, and we're giving it the animations for our bomb, and we're telling what size it is and what palette to use. So that is pretty simple. We have these, this is the pick table here. I'm not going to go over it specifically, but as we saw before, we can put this in. We are calling this field effect bomb function. So this is where our main field effect actually is. If we go into our field effect.c file, we can see this is my Zelda code for my bomb. We start right here, bomb task functions. And to start with, if you haven't seen my task video, you should go back and watch my video on tasks, because I'm not going to go over all the basics around how tasks work. But with these field effect tasks, I define a bunch of specific things in a data field so that we can give them nice names. This is just, I'm not going to go over all the bomb stuff because how I actually did it isn't that important. But the important ones are the state, the sprite ID for the bomb, and the direction that we are facing. And those are stored in data 0, data 1, and data 2. And this is just a data field for the task that we're creating. Now we have more constants, blah, 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 blah. Here is all of the functions for the bomb state that we're going to be calling in this task, because this is going to be a looping task that runs every frame. This is the bomb state functions list. So this is the list. It goes, in order through these functions unless we change it. We can jump from atom start to north, south, east, or west, depending on the direction. This is the actual function that we're running. This is the field effect. So this is the call native. So this script, which is being called from our our script file, our .pori file from the do field effect, this script is just calling this function in a call native. And this call native is creating a task. It's setting up a task bomb. That's this task right here, which runs every single frame. And through the run tasks function, which is in our main callback for our game loop that's running constantly as we're playing the game, at least in the overworld for that run tasks function call. But here we are setting up field effect arguments into these data fields for this task. So when we call our field effect, we can give it, we can pass values from the script to the field effect through these field effect arguments 0, 1, 2, 3. I'm not sure how high it goes, but you can probably keep going a little bit. But here I'm storing the states of all the tiles around the bomb, so I don't have to do it again in the field effect. It's not really that important. I could have just done it in the code here and had it store it in the variables there instead of doing it beforehand. It was just kind of a mess because of where I was in messing with the repo at the time. I was still figuring out a lot of stuff when I wrote this that I have a much better grasp of today. So anyway, we store the positions for the left check, the right check, the front check, and then whether or not there is a rock smash rock, because those are going to be 3 or 4 completely different things that I need to know. I'm setting these bomb animation and bomb animation started to 0. Those are just animation states that I'm going to be taking advantage of in my code when I'm dealing with looping through this task, because this task is going to be running every frame, like I said. So we obviously need to somehow keep track of where we are in the animation. Now that I'm a little bit more experienced with the repo, you can keep track of the animation state of a sprite using some of the fields of the sprite struct itself. There are ways that you can directly access that that make such a task a little bit easier to do instead of manually counting frames like I'm about to do here. But it's not that important at the end of the day. They both accomplish the same thing. One's just a little bit more elegant, and the way I did it is a little bit more of a mess. So here's our basic task. Sets up our field effect, or starts our field effect. It's just while loop. While this is returning true, we keep running, which means if you want to run multiple times in a frame, you can return true instead of return false. But if we return false, then it moves to the next task in the task list. Again, watch the task video if you are confused about that. Then we go to our bomb init. Now this is where I am creating our sprite for our bomb, and this is close to as far as we're going to go in this look into my bomb code. But from here, we're instantiating the player object so that we can have a pointer to the player object instance. That's not the word I should be using, but we are creating a pointer to an object of instruct and storing the player object in it. We are taking the x and y coordinates of the player object, and then we are going to not use them until later. Do I even use them? Do I use normal x and y? No, I think that was pointless. Again, this code is not that great. I should have just used x and y there. Or not, define them at all. But I was probably using them for something else, and then I deleted that something else while I was getting it to work. So let's keep going. We're creating a sprite pointer, and then we're calling create sprite at end. Now this function is going to, we can have only a certain amount of sprites created at a certain time. I think it's 64, but it might also depend on how big the sprites are, how many tiles, 8x8 tiles there are, because there's only so much sprite room in VRAM. But anyway, we are creating at the end of the sprite list the next available spot going backwards from the end of the sprite list. We're indexing from G field effect object template pointers this field effect object bomb. Now we haven't gone over that yet, so we are going to go here. So here, this is where this is. So in this file, source data field effect object templates pointers.h. We need to define define it up here, or declare it up there, and then in this template pointers sprite template array, sprite template struct array, we are going to add, at the end of our list, we are going to add this object template. This object template is the template that we were just talking about, where we, assigned it a palette, we assigned it a pick table and an anim table. That is where this is. If I forgot to go over this field effect object define, these are the field effect objects themselves. As you can see, there are over 60 field effects, but there are only 30 something field effect objects. Not all the field effects use an object. Some of them use the same object as others, but anyway, we are just going to add another object at the end. This is just a number to tell us where in the array we are. It's not that important at the end of the day, but we do need the index of it at the right spot when we're calling it. And so what happens is, when we're creating this sprite at end, we're just pulling this template out, and that template is going into create sprite at end. And that's how create sprite works. It's just pulling the graphics template for the sprite. This is the priority of the sprite. One of the ways of writing the sprite priority. That might be the sub priority. And then here's the OAM priority, which determines which layer it's on in game. And I have it set to if you're on elevation 3, we're going to set it to 2, which is going to put it below the player. But if you're on a different elevation, then we're setting it to 1 to keep it below the player, because the player goes down to 2. It's a little weird, but the player moves elevation, or as the player changes elevation, it also changes the priority that the player is showing on of the sprites. And I didn't want the bomb exploding over, well, I didn't really care as much about the explosion as the bomb itself. When you place it facing northward, if it was above the player, it would show on top of the player's head, and obviously that looks terrible. Anyway, we are going to set sprite position to map chords. This is the player object's position, the player object's x and y position, and we are taking these x2 and y2 variables. Now these are just signed 16-bit integers. Nothing has happened to them yet at this point. So what this is doing is it's not actually setting the sprite position. It's setting these pointers to these variables with the data from these sprite positions. I'm not sure why it's named this way, because it doesn't really make sense, at least to me. But then after that, we are going to set the sprite to the x2 plus 8, y2 plus 8, which is just going to center the sprite in the tile. That's just going to center the sprite in the tile of the player. But we later are going to move it left, right, up or down, depending on which direction we are facing. So from there, we save some data in, but that's pointless because I don't do anything about it. We set it to be invisible for now because I don't want it to display on top of the player. I want it to display in front of the player. So we go to the next thing, we bstate++, which just moves the state of the task function, which moves us down from init to anim start. In anim start, we are just checking the directions. We are changing the position of the sprite depending on the direction that we're facing. If we're facing north, we move the sprite up 16, which is subtracting 16 because y goes down and x goes across. So to go upwards, we have to subtract in this case because we're going from the top left corner of the Game Boy down, across, down and across. South, we add 16. West, we subtract 16 from x. East, we add 16 from x. And then we start the sprite animation, which in this case it's indexing from that anim table that we were talking about earlier. And I created that anim table. I set it up so that the get facing direction anim number function returns the proper animation index for the direction, but you could set up your animation to just be properly indexed for direction instead of the weird swap that the facing direction animation number function uses, but that's how a lot of the standard stuff in the game is done. It's not done indexed using normal, they're the normal directions themselves. So it is what it is, it doesn't really matter. And then we wait for some explosion stuff, blah 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 blah. Some of this is just setting the meta tiles, handling the bomb explosion, the rock smash, the sound, and when we get to the end, bomb end, at the end we run through our task. We need to remove the field effect active list remove, field effect bomb, very important. Field effect graphics, field effect free graphics resources, very important. You do not want to forget either of these. We are removing the field effect from the field effect list. We are freeing the graphics resources for all sprites that we used, all sprites that we conjured into existence. We pass G sprites the sprite ID, which we saved earlier. I didn't necessarily highlight that fact, but we saved it into this task data, field, and we pass that into GSprites and then pass that into this function. That frees the palette, it frees the sprite, so that other things in the world do not get wonky because of your field effect. Then finally, we destroy the task. Find task ID by function, task bomb, and this just destroys task bomb. It's very simple. Well, it's not necessarily that simple, but this is a basic field effect that I wrote. Obviously, I didn't go over it in great detail, but that is how you create a field effect at the end of the day. You need to give it a value in the field effect list. Then we go to the field effect list and we add a field effect script for the field effect. And then we go down and we create a field effect script for the field effect, which we do by mostly just call nativing our task function for our field effect, loading a palette if we need to load a palette. If we are loading a palette, it means that we are likely using a field effect object, which means we need to add a field effect object template to the game, and we need to add the palette for it as well. The template is created in field effect objects.h. We create the template. We also assign the palette some data in this file as well up at the top. We go to event objects graphics if we want to add our file. This is just where we add our object event stuff. And, when we're calling it from a script, we just use do field effect, wait field effect, and set field effect argument. If you are calling it from C and you want to set field effect argument, you just use these global field effect arguments, this global field effect arguments variable, and you just set this at the position 0 or at position 1 or at position 2. You can set it. You don't just have to call from it. So when you're calling a start field effect, let's look up start field effect. Well, maybe it's under a different name, so I'm not going to worry about it right now. It's field effect start. Duh. So field effect start, field effect exclamation mark. So that's just starting the field effect. Here's a good example. And this has 7 field effect arguments. So G field effect arguments 0 is the coordinates of this object event. And this is for the spawn on long grass, which I think means when you load back in from a save or something and you're standing on long grass. This is what it's supposed to do. So we're setting all of this stuff into the field effect, and then we're calling this field effect from our C code, field effect start, and this just calls this field effect. So that is how you set the field effect arguments if you're calling it from C instead of calling it from a script like I did here. Wait field effect just waits for the field effect to be over. It's as simple as that, and that's one of the reasons why I have it done this way. It doesn't really matter. I could have called it from the item function. At the end of the day, it's just really how I chose to do it because of what was going on in my brain at the time. But yeah, that's field effects. They're not that complicated at the end of the day to set up, but what you choose to do with them can be very complicated. It can be extremely complicated. You can get pretty wild with it. Some of the more interesting, interactions in the game are done through field effects. So if you want full control over some of the cooler things in the game, you need to get used to editing these field effects, and especially get used to writing these tasks, understanding how they interact with things like sprites, how they interact with object events, how you can access those object events, access their data, things like their position while you're, inside of a field effect. You do things by, getting the object event, pulling it out of the G object event struct by its object event ID, and then you can access, different things like its coordinates, and you can save that and do different things based on that. That's just the beginning. Obviously, like bow and arrow pulls out the script of an object event and it runs the script remotely from far away. You shoot an object event from 7 tiles away and then it runs its script, which is pretty cool. And that also is handled through a field effect because I'm drawing that arrow. I'm also setting the player avatar state to be the bow and arrow, a bunch of different things. So anyway, I'm going to wrap up the video here because I've been rambling for a bit. This hasn't been exactly the most directed video. I kind of jumped around a bit, so I'm sorry if I caused any confusion, especially at the beginning before things started to come together. If you have any questions, make sure to leave a comment here or in the Discord. Otherwise, I will see you on the next one.